Hello and welcome to C# Logical Puzzles, Games and Algorithms. In this video, we will continue to build our classes for the epic Tortoise versus Hare race. And we already have our base class finished, so we can now create classes of actual runners. So let's start with the Tortoise class. So here's my class, and like all our runner classes, the Tortoise class will also inherit from the runner abstract class. And it will be obviously a public one too. Alright, now let's create a constructor and initialize some of the properties. Now what properties, you may ask? We didn't create any yet, right? But that's not exactly true. We created a lot of properties that all our runners will have in common, and they are part of the runner abstract class. And since we inherit from that class, we have access to these properties, and they are part of the Tortoise class as well. Now we can pass some of the information into the constructor when the Tortoise object is created. In a way, we don't have to do that. We can simply manually initialize everything within the constructor, but just as a demonstration, we can pass some arguments anyway. The ones that make sense for the user to decide on are the name of the Tortoise, the lane the Tortoise will run in, and the current position. Now obviously the current position at the start of the race should be 0, but if we wanted to, we could give the Tortoise some advantage and place him a little forward if we wanted to. So let's pass the current position, and the lane, and the name. And in the body, we will assign the values passed as arguments to the properties. So our current position will equal the current position passed as the argument, the lane will equal the lane, and the name will equal the name. But there's few more properties that we should initialize. And one of them is the move description. Obviously, at the time when our object is created, the Tortoise didn't make any moves yet, so the default description we can display on the screen when the race starts can be simply ready, set, and go. So here my move description will equal the name that the user passes. We can use it here because we initialize the name property before we initialize in the move description. So it could say something like, the Tortoise is ready, set, and go. Alright, and finally, we need to add the Tortoise into the list of runners. Remember, the abstract class has a list of all runners, so as we create each runner class, we should add that runner into the list. And since it's a list, it has an add method to it, so all runners, which is the name of the list, dot add, and we can add the Tortoise, right? So let's try that. But you can see that it's underlined, and it says Tortoise is a type which is not valid in the given context. So what we are going to pass is the whole class. We are calling this add method from our constructor of the Tortoise, so to pass the whole class, we are passing this class. So we use the keyword this instead. So this actually equals to Tortoise. So we are passing the whole Tortoise, whatever we create from now on, the whole class, all the properties and all the methods into the all runners list, so we will have it available from within the list. Alright, so that's the constructor. There's only one more thing we actually need. Since we are inheriting from a runner class, you can see that we need to implement the calculate move method. If I hover over this, you can see Tortoise does not implement inherited abstract member runner calculate move method. That's because we made that method abstract, we have to override it. So I can simply just create it. So here's my override method that overrides the calculate move, and I will specify specific moves just for the Tortoise here. And the first thing we need is to get the random move. That comes from the getMoveType method from the runner class. So we just call that method and assign the return value to a variable. So I'll create a variable move and call the getMove method, moveType method. And that returns the number, the random number generated. And now we need to assign how many spaces the Tortoise should move. Remember that random number is between 1 and 100, which we will use to determine the move. So remember how these moves are assigned? So for the Tortoise, 50% of the time, the Tortoise should move 3 spaces forward, 20% of the time it should move 6 spaces back, and 30% of the time it should move 1 space forward. If you remember from the previous videos, to simulate the percentages, we can simply check if the number is from 1 to 50. There obviously is a 50% chance that it is, because we have a random number from 1 through 100. So 1 through 50 would make 50% chance. To simulate the 20%, we can check if the move number is from 51 to 70, which is the 20% chance that it is, because it's 20 number range. And of course, to simulate 30%, then we can simply check if the number is between 71 and 100. Like I said, that's 30% chance because it's 30 number range. So to put it into the code, we will use an if statement. And first, let's check for the 50%. So if the move is greater or equal to 1 and the move is less or equal to 50, so the number is between 1 and 50, that's the 50% chance, then we are moving those 3 spaces. So I will make move and I will pass the integer spaces 3. Next, we can check if the number is between 51 and 70, which is our 20% range. So else if the move is greater or equal to 51 and less than 70, less or equal to 70, then we'll make 6 spaces back. So we will do make move and pass -6. We are moving backwards. We're supposed to be moving backwards 20% of the time. And finally, the 30% of the time we should move one space forward. So we will do an else statement and we will make the move with just 1 space. And over here, I forgot to type move. So if the move is between 51 and the move is less than 70, then we will move 6 spaces back. Alright, so we could just hardcode the moves just like I did here. But to make the code more readable and to allow for addition of the moves, let's actually put all the moves into a class, and I'll call it move types. So here's my class, and I'm going to make it public. But this class will have nothing but the move types in it, and those will be stored as constants. Basically, we have a bunch of move types like fast plot or slip or big hop. So those are constant because they refer to number of spaces that they represent. So we don't have to instantiate this object from the class, and we simply want to use any given move directly, so I'm going to make the class static. And like I said, here we'll simply use the names of the moves as names for the constants and assign the corresponding value of the spaces to each move. So here's all my moves. The first 3 are for the tortoise and the other 5 are for the rabbit. So fast plot represents 3 spaces, slow plot is 1 space, small hop is 1, and so forth. So I have now all the moves coded as constants, so if I change any values, I can do it here instead of going through all the classes and changing it manually. Now it may not seem like it's really needed, after all these moves are only used by the tortoise and the hare, but imagine if you wanted to raise 100 tortoises and 100 hares. You would need to make 200 changes instead of just 1 in this one class. So we can go back to our tortoise class and we can replace the hard-coded values with the move type values. So instead of 3, we are going to move the fast plot, which represents the 3 spaces. So we will pass the integer that corresponds with the move type dot fast plot. And you can see now why I made it static, because I don't have to instantiate the object. I can just type the class name and then have all the constants available to me. Now -6 spaces is corresponding with the slip, so it's gonna be move type dot slip, and the 1 space for the tortoise is the slow plot. So we have the move types passed instead of just hard-coded the numbers. Like I said, imagine you had 100 classes and you would have to go through each of these moves and change each of those numbers. Now, after we make the move, there's one more thing I want to do. I want to display what move was actually made, so we can verify visually how the turtle is actually moving across the board. So after we make the move, I'm going to change the move description, and I'm going to assign the name of the move to it that will be displayed on the screen. So our move description will equal and I'm going to do the string interpolation, and I'm passing the name, which is going to be the Tortoise name in this case, and we can say something like the Tortoise moved fast blood, and just so we know, we'll type +3. It's not necessary, but just for the visual, for our own kind of like testing purposes. And we'll do the same for the other two moves. So this one is the slip, so I'll just copy paste it, and I will do the Tortoise slipped, -3 spaces. Actually it's -6. And finally the slow plot, I will simply say the Tortoise made the slow plot, which is +1 space. Alright, so that's my calculate move method for the Tortoise. I actually forgot one property which we should actually assign a value to, and we could do it either as an argument that the user would pass into the constructor, or we can in this case just do it directly in the constructor. And the property I'm talking about is the runner symbol that will appear on the racetrack. So the runner symbol for the Tortoise would be capital T, and when we create a Hare, it could be capital H. Okay, this is all for the Tortoise class. Notice we didn't need any variables or properties. They all are available through the runner class, and they will be available for the Hare class as well. Again, imagine how much time and code we are saving this way if you wanted, let's say, 100 tortoises and 100 hares. Instead of having each of them their own properties, they all share the same properties and have them available from one class only, which is the runner class. Alright, so thanks for watching, and I'll see you in the next video when we will code the Hare class.